Yeah. The relationship between fluxes will start from here. So Na, we are denoting one type of flux, Na or Ni. The meaning of this Na or Ni is flux with respect to stationary coordinates. Then Ja or Ji is another type of flux, which is nothing but flux with respect to arbitrary coordinates. So the relationship between fluxes means there are two types of fluxes, Ni or Ji. So the relationship between these two we have to derive. So how to derive this relationship? So we already know. So we know the definition of this stationary and arbitrary coordinates. You can watch the previous videos. In that one, we have taken an example that one stream of water is there in which sailor is there. One sailor is just observing a controlled volume, in which the fishes are just moving. So that control volume, based on that one, if this observer is also moving with some velocity, so he will also have some velocity. And if this observer is not at all moving, he is stationary. So in this ship, if he is stationary, so when he is observing the fishes inside this control volume, so under this region, we can say U naught is equal to 0 by standing at one single point. If he is just observing how many fishes are there inside this control volume, then that point is known as he is not at all moving from here, stationary. He is standing at one location. Because of that, his velocity is 0. But other term is U naught. When this person is also moving inside this, fishes are also moving. Fishes are not at all stationary. Here also fishes are moving. Here also fishes are moving. But here, along with this fishes, this sailor is also just moving along with the stream. So he should have some velocity. So that is called U naught. So here U naught is equal to 0. Why? Because he is at a stagnant point. He is at single point. So based on this example, we can define what is Ji or what is Ni. So Ji is equal to Ci into Ui minus U naught. Ji is equal to Ci into Ui minus U naught. This is by definition of flux. So if you check the units of this one, so units of concentration is mole per meter cube. Then velocity units are nothing but meter per second. So if you can cancel out this one, we will get mole per meter square second. Now you can define what is flux. Flux is nothing but moles of component transferred So this is the unit for area. Per unit area per unit area per unit time. Seconds means time. So flux is nothing but moles of component transferred per unit area per unit time is nothing but the definition of flux. So this is the formula for the flux, and similarly for Ni also at stationary coordinates we can define in such a way here Ci into Ui minus U naught. Here U naught is equal to 0. Why? Because this sailor, he is not at all moving. He is at stationary point. U naught is equal to 0. Here U naught is not at all 0. So Ni is equal to Ci into Ui is the definition of that stationary flux with respect to stationary coordinates, and this is flux with respect to this is stationary coordinate, and with respect to arbitrary coordinates, this one is the definition. So now we have to find out what is the relationship between these two. How can we find out? By the definitions, we can find out the relationship. So by the definition, Ji is equal to Ci into Ui minus U naught. So here we can also define this one. Ui is nothing but velocity of components. Like it can take value of I is equal to A, B, C, D, etc. How many components are there or how many fishes are there? If you can label with A, B, C them, so those are that values. Then U naught is equal to This is also velocity of observer. Okay, it will be constant because u0 is nothing but is stationary, one velocity. Okay, that boat velocity. Okay, that sailor, whatever the velocity of that sailing boat is there, that velocity is nothing but. So velocity of observer. So how to find this one? So by definition, we know in order to uh, uh, this u naught is defined in three quantities. One is mass velocity, then molar velocity, then volume velocity. Okay, average velocity we can say. Okay, mass average velocity, because we cannot find a single point. Why? Because stream is just moving. Okay, this tides. Okay, we can call this as a tides. Tides are just moving like that. This stream is also moving, and along with that, sailor is also moving. Boat will have one speed. Okay, boat speed will be there, and this tides, whatever the tides are there, this is also will have some speed. So tidal speed is there, whether it may be opposing. Okay, he may be opposing and going to the forward direction. When the this tides are going in the same direction in which the sailor is moving, then the boat will be moving at a very fast. But when the tide is moving in this direction, opposite direction to the direction which is moving by this boat, he has to apply some additional force. The speed will be somewhat resistant. The speed will have some resistance. So because of that, he will be moving at less speed when he is moving in opposite direction to the direction of this tide. When he is moving in the similar direction with respect to the tide, so he will be moving fast. So resistance will be very low here. So we have to consider all these points. Well, what is the direction of a tide? What is the speed of a tide? What is the direction of a boat? What is the speed of a boat? Okay, how he is operating? All this we have to take into consideration. But it is not possible to take into consideration what is the speed here, what is the speed here, what is the speed here. So it is best to take the average of all these speeds. Then we can summarize that this is nothing but average speed. So mass average velocity we can define with some mass average velocity, then molar average velocity, and another way is volume average velocity. Okay, like this we can define this u naught value. So to define u naught, we have three quantities. One is mass average velocity, next one is molar average velocity, then volume average velocity. So out of this, for the definitions of all these three, you can look the previous videos, or otherwise we can define here. U naught is equal to sigma I is equal to 1 to n rho I into ui divided by sigma species I is equal to 1 to n rho I. So this is for mass average velocity. Then volume average velocity we can define u naught only, but here when these are mass terms, you have to denote with hyphen mass, and this is mole. U naught mole is nothing but sigma I is equal to 1 to n Ci into ui divided by sigma I is equal to 1 to n into Ci. Like this you can define. And this also u naught volume is equal to sigma I is equal to 1 to n molar volume into this one ui. Like this, three quantities you can define. But largely what happens in mass transfer problems, we will use all the terms in a concentration terms. So the fluxes will be defined in a concentration terms to a large extent. To a very limited extent, we will use these formulas in the mass average velocity and volume average velocity. But according to the best of my knowledge, in every problem, in every derivation, we will use this formula very much. But you have to remember this formula and this formula also. But you can use this one here. So we can substitute. If you can give some equation number here 3, then substitute this equation 3 in equation this equation. So Ji is equal to Ci, we will multiply with this one, Ci into Ui minus Ci into U naught. So in place of that U0, we have to substitute that one. So Ji is equal to Ci into Ui minus Ci into U0 is nothing but in terms of molar average velocity is sigma I is equal to 1 to n Ci into Ui divided by sigma I is equal to 1 to n Ci. So now we have to use our very basic formulas. What is the definition of mole fraction? What is the definition of weight fraction, like this? So now we will see. So what is the meaning of this term? Ci is nothing but concentration of species I. I can have a value A, B, C, D or 1, 2, 3, 4. You can take a value. But what about this one? This definition, summation of I is equal to 1 to n Ci. Meaning, see if I is equal to the sum A, then B, C, D, like this values are varying. So we can say sigma means summation of up to n components. N may be some 2 components. For example, say Ca plus Cb plus Cc plus Cd. If there are 4 components in the system, so total summation we can say it is nothing but concentration, total concentration. We can define it as total concentration Ct, or in a general term capital C. We can define this is a total concentration where C is equal to total concentration of all the species. Ci is nothing but individual species for one component, individual concentration. For example, say I is equal to A. This is Ca, concentration of A in that mass transfer operation. Whereas C means without any subscript or superscript. So this is denoted by this total defined by total concentration of all the species in the system. So this is C. Then what is the meaning of this one? Ca into Ui. Ca into Ui is nothing but concentration multiplied by velocity. We have defined earlier, which is nothing but flux with respect to stationary coordinate Ni. Flux with respect to stationary coordinate, that definition. So Ca into Ui is nothing but flux with respect to stationary coordinate system. Then what is the meaning of this one? Summation of all the components from 1 to n into Ci into Ui. So this we can write as like this one, I is equal to 1 to n Ni. In place of Ci into Ui, we can write Ni. So this is nothing but the meaning of this one is summation of n number of species which are present in the system. So Na plus Nb plus Nc plus Nd plus like this so on. So we can define this as some n. So this is total flux where n is equal to total flux of all the species present in the system. So this is total concentration, this is total flux. Now we can define the same terms here. Ji is equal to, this one is Ci into Ui is nothing but Ni from here, then minus Ci divided by this summation of Ci is nothing but this one C. From this definition, we can consider this as C into Ci into summation of Ci into Ui is, from this one we can write this as N. So this is into N. So we got this one. Then what is the definition of mole fraction? Mole fraction is denoted by X, or Xi is equal to, mole fraction is nothing but individual concentration divided by total concentration. For example, say for component A, Xa is equal to Ca divided by C. Xb is equal to Cb divided by C. This is nothing but mole fraction is nothing but ratio of individual concentration to the total concentration is nothing but mole fraction. So this is mole fraction. This is Xi. So Ji is equal to Ni minus Xi into N. So now we can write this as Ni is equal to, just we can change this one here. Ni is equal to Ji plus Xi Ni. So this is the relationship between fluxes. So Ni is nothing but flux with respect to stationary coordinate. Ji is nothing but flux with respect to some arbitrary coordinates. So this one is the relationship between fluxes. Okay, is that okay? Have you understood this one?
Yes, sir.
Yes, sir.
Yeah, I will proceed to the next topic, which is very, very important. That is nothing but show that DAB is equal to DBA. So how to show this one? DAB is equal to DBA. How to show this one? So in order to prove this one, DAB is equal to DBA, what are the equations that we want here? So equation first one is, we want fix the first law of diffusion. First law of diffusion we want. So what is fixed first law of diffusion? Ji is equal to some Ja terms we can write. Ja is equal to some DAB dou Ca by dou Z. So this is fixed first law of diffusion. Then the next equation we want in our hand is relationship between fluxes. Relationship between fluxes. Just now we derived this one. This is nothing but Ni is equal to Ji plus N into some Xi. So this is relationship between fluxes. I am giving once again the equation numbers, which will be clash with the earlier. You have to just differentiate between them. So this one equation 1 and this one is equation 2 if you consider. From equation 2, now what happens? Apply equation for component A. Component A. What happens for component A? If you apply this equation, in place of I, we have to substitute A. Na is equal to Ja plus N into, in place of I, we have to substitute A. So this one we will get plus Ja. From equation 1, we can write Ja value. What is Ja? Oh, this is minus. Ja is equal to minus DAB dou Ca by dou Z. So Ja is equal to minus DA dou Ca by dou Z plus N into Xa. Yeah. Okay. N into Xa. This one will give equation 3. Then next is apply equation 2 for component B. So in place of this I, we have to substitute B. So NB is equal to JB plus N into XB. So what is the value of JB then? Fixed first law of diffusion for the component B. So we can write this is minus DBA. So this is diffusion of A to B, A through B, and this is diffusion of B through A. Why? Because we are defining the flux with respect to B component. So this will be concentration, change in concentration of B with respect to some spatial coordinate. Will be the equation. Now this equation we have to substitute here. So NB is equal to, in place of JB we can write minus DBA dou CB by dou Z plus NXB. So this one is N into XB. So we will give some equation number 4. Now add equation 3 and 4. So we have to perform a summation of equation 3 and 4. So equation 3 is NA. From equation 4 it is NB. So we have to perform this operation. So from this one we can write minus DAB dou CA by dou Z, then plus summation of this one. So plus into minus is plus and minus is minus. So this is DBA dou CB by dou Z. Then summation this one, left out terms, N into XA, N into XB. So N into XB. Now what we can do, there are only two components in our system. So NA plus NB is nothing but N. We can write N is equal to, these terms we can write here, N XA plus N into XB minus DAB dou CA by dou Z minus DBA dou CB by dou Z. Now we can take the common XA plus XB, here N is there, minus DAB dou CA by minus DBA dou CB by dou Z. So what is mole fractions? Sum of the mole fractions. Now we are assuming only two components are there in the system. Two components are there in the system, in your mass transfer system. Then what happens? Total flux is equal to NA plus NB. So components are only two components, A and B. The mole fraction. What about the mole fraction? So mole fraction is equal to XA plus XB. Then sum of the mole fractions is nothing but equal to 1. Why? Because it will be a fraction. Fractional amounts, when you are just summing up for the overall system, it will be coming only 1 only. So this will become 1. So this is equal to N is equal to N minus DAB dou CA by dou Z minus DBA dou CB by dou Z. So this one N and N cancel. Now if you take this one here, this to this side, on the LHS side, it will become positive. DAB dou CA by dou Z is equal to, here the negative only will be there, minus DBA dou CB by dou Z. So up to here you obtain this one. Now what we have to prove? DAB is equal to DBA. But here DAB not equal to DBA. Why? Because it is having these quantities. We have to take out these quantities. How to take out these quantities? So we know the mole fraction. What is the mole fraction of component A? XA is equal to individual concentration of component A divided by total concentration of the system. Then this is, next one is mole fraction of component B is CB divided by C. From this definition, what is CA? CA is equal to C into XA. Then from this definition, CB is equal to C into XB. Same thing, you have to apply these definitions here. So this is DAB. In place of your CA, you have to apply this equation. So C into XA. So this one is quantity, this one. Dou Z is equal to minus DBA. So this, by this definition, CB is nothing but C into XB. So dou C into XB divided by dou Z. So the concentration, the total concentration is not at all a variable. Since it is a constant, we have to take it from the derivative. Why? Because it's a total concentration. Individual concentrations will vary, but total concentration will not vary. So this C we have to take from the derivative outside. So this will be dou XA by dou Z. Then this is also similarly concentration. Total concentration is constant. So we have to take out from the derivative. So dou XB divided by dou Z. We can cancel out this C and C. Now also, if you can see, there is no equality between DAB and DBA. Why? Because there is one minus is there. Here dou XB is there. So how can we cancel out these terms? We know this fact, xa plus xb, sum of the mole fraction of the system is nothing but 1, equal to 1. Then by this definition, what is xb is equal to 1 minus xa. Now you apply the derivative for this equation. Dou xb with respect to dou z is equal to derivative of 1 is 0. Then derivative of xa is dou xa divided by with respect to z. So now we can write this as dou xb divided by dou z is equal to minus dou xa divided by dou z. So this our equation. So in place of dou xb by dou z, we can substitute this one. So we have to substitute here that one. So this is DAB dou xa by dou z is equal to minus is there. So DBA. So in place of this dou xb by dou z, we have to substitute this one. This is minus dou xa by dou z. So this is minus into minus is plus. This will become, so this will become only DBA dou xa by dou z. Then here DAB dou xa by dou z. Now the common terms we can cancel out. Dou xa by dou z, dou xa by dou z. Then we have proved this one, DAB is equal to DBA. Hence prove. So they can ask this question like prove that DAB is equal to DBA or show that DAB is equal to DBA. Then you have to apply all these formulas, all the knowledge. Then you can prove this DAB is equal to DBA. Is that okay? Is there any doubts in this one?
No, sir.
Okay. Yeah. So this was already there in the notes. You can just verify that one. Okay.